All right, I hope you did part 1 and you did the example problems that I had from the homework pages. Right now this is part 2 of solving radical equations. It gets a little trickier, and there's things that we're going to need to remember like perfect square trinomials, binomial squares, and dots problems. I'm going to do page 264, numbers 5, 6, and 7. You're going to try page 266, 15, 17, and 19. Let me know how it goes in class. Number 5. All right. We have x's on both sides, and that is a huge, huge problem in math. You can't have x's on both sides. You need to bring all the x's to one side. Problem is that this x is trapped underneath that radical. So it looks like the only thing I can do right now is square both sides. All right. Seems pretty simple here because the square root and the square are going to cancel out, and I'm left with 10x plus 9. Over here, not so simple. Here's where your multiplication and your factoring of perfect square trinomials comes in handy. This is a binomial square, so we're going to square the first, we're going to square the last, we're going to squeeze and double. Now I have something that we've done back in chapters 2 and 3. I just have a quadratic. I don't know what it's going to look like, but I know that I need to get 0 on one side. So let's take away 10x by lining up like terms. 10x minus 10x is 0. 9 minus 9 is 0. So I just have 0 on this side. X squared doesn't have any friends. 6 minus 10x is negative 4x. And then lucky us, 9 minus 9 is 0. So right now I have 0 equals x squared minus 4x. And you need to think. Is there a GCF? What kind of factoring problem is this going to be? Because it could be anything. I do see a GCF. I see that I can take out an x. So I'm going to take out an x. When I take out an x out of x squared, x is left over. When I take the x out of here, negative 4 is left over. So I can see that my answers are 0. From the solo x, and then 4, because we're going to change the sign on the factor. So this is what I think my answers are. Not all the answers you get with these types of problems are actually going to be the answers. We actually need to go back, plug them into the question to see if this side equals this side. We have to do it. There will be trick questions. We don't know if all of them are going to be right. So let's plug in 0. 10 times 0 is 0, and 0 plus 9 is 9. The square root of 9 is 3. Let's plug in 0 over here. Remember, I'm just looking at the black. That was what my original question was. Look in your book for the original question. 0 plus 3 is 3, so I have 3 on both sides. 0 is an answer. Check mark. Save it for later. Let's do 4 now. Let's change the colors to green. 10 times 4 is 40. And 40 plus 9 is 49. The square root of 49 is 7. Plug in 4 for x. 4 plus 3 is 7, so the other side is 7. Remember, again, we're just looking at the black. 7 equals 7, which means 4 works as well, and these do turn out to be both my answers. We're lucky in this case. It doesn't always work out, as I told you before. Okay? This is a lot to handle. 2 x's, get rid of the radical, binomial square to perfect square trinomial, some sort of factoring over here, changing the signs. That's what it's going to be. So let's take a look at number 6. We can get another example. Okay. Number 6 says... 2 square roots on each side. These are actually really good. The math is simple. The checking the work is the same. You still have to do it, but you at least could probably spend less time. All right. So, sorry, we got some... All right. Okay, x's on both sides. They're both under radicals. There's no plus or minuses outside. So I'm going to square both sides. I think you can get an idea of what the first step is. We're going to be squaring both sides. The square and the square root cancel out. The square root and the square cancel out. and no squares for the x's, which is great. I can just take away x, take away 5, and it looks like x equals 2. But it might not be the right answer. In fact, for this one, since we don't have 2 answers, there might be no answer, or there could be 1 answer. So let's go back. Let's plug in 2. 2 times 2 is 4. 4 plus 5 is 9, and the square root of 9 is 3. 2 plus 7 is 9. The square root of 9 is 3. So 3 equals 3. 2 actually turns out to be our answer. If it wasn't, we would write down no solution. You're probably going to come across that in class tomorrow. Okay? So these are nice. Squares everything. You just square everything. The square roots cancel out, and you're usually left with just a normal Algebra 1 simple 2-step problem. All right, on to number 7. All right, this one is going to take some time, so make sure you pause a lot and write down notes to yourself. Remember, if you're just writing down the math and you have no explanations of what I said or what I'm doing, why I'm doing it, then you're probably not going to understand it a few days from now, because I know I wouldn't when I was your age. Okay, here's a huge problem. We have a square with something outside the square and then a square by itself. The only thing I can think to do is try to get rid of this square root first by squaring both sides. Okay. Let's go to this side because it's easy. That side, I'm actually a little afraid of. Square, square. They cancel out, we get x minus 2. Over here. This is really a binomial square. It's going to turn into a perfect square trinomial. Square the first. Square the last. Are you with me? Square the first. We just cancel that out. Square the last. 2 squared is 4. Squeeze, we get negative 2 rad x plus 4. Remember, squeeze means multiply. Squeeze, we get negative 2 rad x plus 4, and double, we get negative 4 rad x plus 6. And then there's a plus 4, okay? I'm going to write this again neater. But here we squared first. This just cancels out. Easy. This one, a huge mess. But we have to follow our binomial square to our PST rules. Square the first, radical goes away. Square the last, that's easy. Squeeze and double, we're smushing out the radical with something else. So right now we should have x plus 6 minus 4 rad x plus 6 plus 4 equals x minus 2. All right, here is the thing that I need to start isolating, right? This is the weird looking thing. I'm going to try to get that by itself. So, first of all, minus 4 plus 4, they cancel out. Oh my god, actually, I'm completely wrong. Let's go back, because this is a term. I can't do that. Holy crap. All right, so 6 plus 4 is 10. I can take away x from both sides. That's going to go away. So I have 10 minus 4 rad x plus 6 equals negative 2. Let's take away 10 from both sides. I'm slowing down the Algebra 1 stuff right now. Negative 4 rad x plus 6 equals negative 12. Let's divide both sides by negative 4. Rad x plus 6 equals 3. I'm going to try to write over here. I'll say what I'm doing out loud. I hope the glare is not too bad. We're left with the square root of x plus 6 equals 3. I'm going to square both sides. And then I'm going to take away 6, and my answer should be 3. I have to go back and plug it in. Oh, 1 second. Pause. So, sorry, Gus is here. Say hi.
Hello.
I let him jump in. So you have to take 3, you got to plug it in. 3 plus 6 is 9, the square root of 9 is 3, and 3 minus 2 is 1. So this side is 1. Plug in 3. 3 minus 2 is 1, the square root of 1 is also 1, so 3 works. If I were you, I would stop, pause, go back, and redo this problem with me before you head on to 15, 17, and 19. Be back for part 3.